importance. As we look back into history, we find remarkable examples of ingenuity in early timekeeping devices. Sundials, for instance, were among the earliest timekeepers used by civilizations like the Egyptians, Greeks, and Romans. These devices relied on the position of the sun's shadow cast upon a marked surface to indicate the time of day. Sundials not only provided a practical means to tell time but also demonstrated a profound understanding of celestial movements. Water clocks, or clepsydra, were another remarkable invention. Employed by ancient civilizations like the Babylonians and Chinese, water clocks operated on the principle of regulating the flow of water from one container to another. The gradual filling or emptying of a vessel allowed people to approximate the passage of time. These early timekeeping devices were instrumental in activities ranging from agricultural planning to religious ceremonies. However, it was the conceptual leap of dividing time into hours, minutes, and seconds that truly marked a revolutionary moment in the history of clock engineering. The realization that time could be systematically organized into smaller, measurable units demanded not only mathematical precision but also intricate mechanical design. This innovation laid the foundation for the development of more sophisticated timekeeping instruments, ultimately leading to the creation of mechanical clocks. The transition from sundials and water clocks to mechanical clocks was a pivotal moment in the history of timekeeping. These early mechanical clocks, which emerged during the medieval period in Europe, were intricate marvels of engineering. They employed gear systems, weights, and escapement mechanisms to regulate the flow of energy and maintain consistent timekeeping. These clocks found their way into monasteries, town squares, and eventually private homes, shaping the daily routines of societies and enabling synchronization of activities. In essence, the engineering behind early clocks transformed the way humans interacted with time. It allowed for more precise scheduling of tasks, better organization of work, and the evolution of societies into more structured and efficient entities. The concept of dividing time into hours, minutes, and seconds, which began as a revolutionary idea in ancient civilizations, has become an integral part of our daily lives, thanks to the intricate and visionary engineering that brought these ideas to life. This rich history of timekeeping devices is a testament to humanity's eternal quest to master time and to create instruments that resonate with both artistic beauty and scientific precision. One of the most critical developments in clock engineering was the invention of the escapement mechanism. This ingenious invention, attributed to various inventors throughout history, including Galileo and Huygens, made precise timekeeping possible. The escapement regulates the release of energy from a wound spring or falling weight, allowing the clock to tick at a constant rate. The invention of the escapement mechanism marked a profound turning point in the history of timekeeping. Before its development, early clocks lacked the precision required for accurate time measurement. These early timekeepers, including sundials and water clocks, were inconsistent, relying on natural phenomena like the sun's position or the flow of water. The concept of dividing time into equal intervals was a daunting challenge for clockmakers of the time. The escapement, often attributed to various inventors including Galileo Galilei and Christine Huygens, brought about a transformative breakthrough. It introduced a method to control the release of energy from a clock's power source, whether it was a wound spring or a falling weight. This control was achieved by employing a set of interlocking gears and levers. The escapement mechanism essentially acts as a brake, allowing the energy source to advance the clock's gear train at a precisely regulated rate. When the escapement releases a tooth of the gear, it produces the familiar tick that we associate with mechanical clocks. The escapement's ingenious design ensures that each tick of the clock corresponds to a consistent interval of time, creating the basis for accurate and reliable timekeeping. Furthermore, escapements are designed with incredible precision, often involving intricate calculations to determine the size and shape of the escapement wheel's teeth and pallets. These considerations are crucial in ensuring that the escapement operates with minimal friction and wear, contributing to the clock's longevity and accuracy.